Hey everybody, I am now going to walk you through the video analysis for your self-propelled vehicle. So, first thing you have to do is shoot a video. It should be only 5 to 10 seconds long. Please, should not be any longer than that, really. Needs to be in landscape mode. That means hold the phone horizontally. You want to have a meter stick somewhere in the frame. You are literally just going to have the phone directed straight at the action, like over top ideally, as though you are above it, and try to have the car go from left to right. And also, make sure you capture the car moving at least 1 meter. You don't have to capture all of the motion. You just want to try and get it from start to when it goes out of frame. But again, be holding it above. Once you have your video done, then you want to save it in your Google Drive or on your computer desktop and launch the video analysis link. And that is right here on the lab. This will come up, video analysis. We have a site license to us. You will choose the file, and I'm going to choose a file that I shot a couple of days ago. Max helped me with this one, Max Berman, and he rolled a ball for me. So the first thing that you need to do is you're going to click on System, and you're going to set the scale. Basically what you're doing is you are telling the program how long 1 meter happens to be. So stretch the circles into the end, and then up here it's going to say 1 meter. You could also make that 100 centimeters if you want. In fact, that's what I'm going to do. I'm going to do 100 centimeters. Type that right in there. Now that sets my scale. 401 pixels, 100 centimeters. Okay, next you want to set the origin. I would put it somewhere over here. It's not that important exactly where you put it, but kind of close to the beginning. Well, you want it before the beginning, ideally. Next, I'm going to hit play. Now you'll see why. Oh, and now I stop it. As soon as the ball starts to move, I'm going to back frame a little bit to right about when it leaves Max's hand. Right there. That should work. We're almost done, believe it or not. Next thing we have to do is click on Add, which I don't think is actually going to be in the frame here, unfortunately. Let me see if I can make that. Okay, put that in the frame. Add points and track. Take this bullseye and put it all on the center of, in this case, the ball. For you, you're going to put it onto a very prominent point on your car, something that is really easy to see. And once you start auto-tracking, the program should do all the work for you. And it pretty much does. It lost it a little bit there in the beginning, you can see, but it tracks it until the video has basically ended. Now, if you take a look over here on the right, I'm going to stretch this out a little bit. Maybe. There's my graph. We actually only need the red dots. The red dots represent the X or horizontal motion. So I'm going to click off of Y. We don't need that. And that's literally just going to give us this graph. Now save, or better yet, print out a copy of the graph. Now there's a lot of data here. You can read data directly off of the table, but you won't need it for this particular graph. So just print this graph out. And then after you print this position or X graph, X versus time, switch it over to X velocity and then get rid of X position. Why? Well, that tells you what happens to the velocity. That can tell you where it has its maximum value and its minimum value. You want to find the maximum value of the velocity. Now it looks kind of like it's up here, way up here, but I'm going to guess that that's kind of a mistake. So I would probably put it at this point right there, which looks like about, oh, you can click on it and it'll tell you 60.62 centimeters per second. That is your maximum velocity, and that occurs right down here at 0.10 seconds. Then you want to find the minimum velocity, which, oh my goodness, click right there, and that's about 30.1 centimeters per second, and that occurs at 2.67 seconds. Why do you need that data? Because you want to figure out how much the velocity changes. It goes from about 60 to about 30, and you want to find out the amount of time that takes, which was 0.10 to 2.67. Those data will help you find the acceleration. And that's really how it works. That's all there is to this. So again, you want to write down those numbers, write down what the starting velocity was on that dot 60.62 at a time of 0.10 seconds. And then write down the lowest velocity over here, which was 30.10 centimeters per second at 2.67 seconds. And you really could have done it over here too. That would have been fine. But yeah, 31.14. And that's, in this case, 2.77 seconds. So, to do the actual calculation, you will calculate the acceleration. Let me show you how that happens to be done. Okay, so acceleration is going to be equal to the change in velocity divided by the time, which for this would have been 60, roughly 60 minus 30, I think it was 31, and then you divide that by the change in time, which was, about 2.7 minus 0.1, and that will give you a particular number. I can work that out right now. So let me see, 60 minus 31, that equals 29. Divide that by 2.7 minus 0.1, which is 2.6. And that works out to be 11 centimeters per second squared. I don't think I could fit the units in here, but centimeters per second per second. Okay, that's how it works, everybody. Good luck.